Good afternoon, everybody. It is the Bearded Tangent, and today we're going to look at graphing cosecant and secant functions. So we've looked at how to graph sine and cosine functions, so we'll be graphing the reciprocals, and later I'll be posting a video on how to graph tangent and cotangent functions as well. So to graph a cosecant function, which is what we'll start with, the first thing that we want to do is graph the sine function. So we know that sine and cosecant have a reciprocal relationship, which means that sine is going to equal 1 over cosecant, and cosecant is going to equal 1 over sine. So if I graph my sine function, I can take my points on the graph of the sine function, and I can use those to graph my cosecant function from that. So we remember that a sine function starts at 0. At pi over 2, it's at 1. At pi, it's going to be at 0. At 3 pi over 2, it's going to be a negative 1. And at 2 pi, it's going to be at 0. So if I graph this function, it would look like this. All right, let me draw this full. It's a little bit difficult to see. All right, so this will be my sine function. Now, we can take a look at where the function is at these points and get our cosecant function from that. So we have 0, we have pi over 2, we have pi, we have 3 pi over 2, and we have 2 pi. So at 0, my sine function is at 0. At pi over 2, we're at 1. At pi, we are at 0. At 3 pi over 2, we're at negative 1. And at 2 pi, we're at 0. Now, to graph my cosecant function, I know that all my values of cosecant will equal 1 over the sine function. So these are all the values of my sine function. So if I wanted to find out what my cosecant graph would look like, I can put each one of these underneath 1, and this will tell us what our cosecant graph is going to look like. So if I, for instance, have 1 over 0, this is going to be an undefined value. Undefined. 1 over 1 is going to give me 1. 1 over 0, another undefined value. 1 over negative 1 is going to be negative 1. And again, 1 over 0 gives me undefined. So what I'm going to have is a graph that is going to have 3 undefined marks, and I'll show you what those will look like, and then a 1 and negative 1 point. So if we were to graph undefined, this is going to be a vertical dotted line that we call an asymptote. So we'll have one of those at 0, at pi, and at 2 pi. So there are asymptotes at each one of those locations. Where sine is 0, cosecant will be undefined. Where sine was 1, cosecant will also be 1. And where sine was negative 1, cosecant will also be negative 1. And since they're reciprocal in nature, we flipped the graph. So this sine graph is kind of making a frown face. It's opening downward. So our cosecant graph will flip upwards. This graph is opening upward, kind of making a smiley face. So our cosecant graph will flip downwards, making a frown face. So that is what the graph of cosecant looks like. It's just the green portions of the graph. If you get pretty good at this, you could technically graph this without drawing your sine graph. However, drawing the sine graph makes it a little bit easier to put your points down and draw your cosecant graph off of that. So now let's take a look at our secant graph. So just like we used the sine graph to find cosecant, we know that cosine and secant have a reciprocal relationship. And so we can use a cosine graph to find out where our secant points will be. So a cosine graph is going to start at 1. At pi over 2, it's at 0. At pi, it's at negative 1. At 3 pi over 2, it's at 0. And at 2 pi, it's going to be at positive 1. So our cosine graph for our parent function will look like this. Alright, so again, we could come in and put 0, pi over 2, pi, 3 pi over 2, and 2 pi. And at 0, my cosine graph is at 1. At pi over 2, we're at 0. At pi, we are at negative 1. At 3 pi over 2, 0. And 2 pi, we're back at 1. Okay, and just like we did with cosecant, we come in and we put a 1 over each one of these cosine values, and that will give me my secant values. So we'd see here 1 over 1, much like we had up here with sine. So this is going to equal 1. 1 over 0 is going to be an undefined value. 1 over negative 1 would give me negative 1. 1 over 0 would be undefined. And 1 over 1 is going to give me 1. So where my cosine graph is at 0, I want to draw my asymptotes. These vertical dotted lines. And then at 0, we are both at 1. At pi, we are both at negative 1. And at 2 pi, we are both back at 1. And so then my graph would just be the flipped version of each of these graphs. So there, these points that are coming off of a cosine graph would be your secant graph. So you're just taking those and flipping what the cosine graph is doing inside each of those asymptotes. And we can use this to graph with different amplitudes and periods and phase shifts and vertical shifts, just like we can with sine and cosine. In fact, it's the exact same thing as with sine and cosine. You're going to graph the sine and cosine graph first, and then phase shift it, and then you would graph your secant or cosecant graph off of those. So if you can graph a sine and cosine graph, you should have no problem graphing a cosecant graph and a secant graph, because they are both just based off of their reciprocal graphs. So I'll post a video shortly on how to graph tangent and cotangent. Thank you guys so much for watching. We'll see you next time.